Or like an official like AP score person
Yes.
graded mine, would they have given me the same score that you gave me? Well, they have to do holistic scoring, so would it have been a 3 out of 4 on the back part of the strip?
I'm afraid so, for simply leaving out the word random.
Okay.
You suddenly got a 3, which is terrible because
That
the
is
response
terrible.
is so good.
Bullshit.
But they explain in their scoring guide, like
It's okay, just say it.
if the student doesn't explain that it was a random design, then it's a B.
We're recording, it's fine.
So it really stinks. But again, they were really good. That was it was your best 3 response yet, but we thought it was going to be. It was supposed to be. And the fact that I didn't have more perfect is why I'm slightly disappointed. Only slightly. Oh, goodness. Okay, so we were talking about probability.
Of course.
Which is our second new favorite topic because
I don't like this topic.
What's our first favorite topic?
how to sample. Sampling and experimental design from the last chapter. Oh, yes. This is it. So, I got a funny look when we were talking about this on Friday, so I wanted to go back over it. So, there's this theorem, or this formula, that you don't have to memorize. And we were talking about 2 symbols, which you do need to get to know, because they're going to ask them in this form. Not that you have to write your response in this form. They're going to ask them in this form. They might say PA, and then it looks like an N. It means the intersection. So PA is the probability of A intersected with B. And then the one that looks like a U is the probability of A and B. So we've got an and an or kind of situation thing. And anyway, moving on. The notation gets tricky in that regard. You don't have to memorize this formula, but I got to look when we were talking about this formula. So if we're trying to figure out the probability of A or B happening, or both, we're going to add up the probability of A. We're going to add up the probability of B. But then we have to subtract out this middle region. And the reason we have to subtract it is because the first circle counted it, so A counted it, B counted it, so right now it's being counted twice. So that's why we have to subtract it out, because you can't count it twice. It's an overlap. Both circles share it. You've already counted it with A. You counted it again when you counted the probability of B, so that's why we have to subtract the overlap. So that was the funny look I got on Friday, so I wanted to address that again. Okay, so if we're happy with that, then let's move on to the next question. Distance learning courses are rapidly gaining popularity among college students. Here is a probability model by age of the proportion of students taking at least one distance learning course. Unsurprisingly, over 40 is only 0.12. That's when you, well, it depends.
This is a meter. This is a foot. This is a yard.
Well, no, when I did distance learning, it was like I took a class where we met on Saturday. Yeah, I had a class on Saturdays, and we would meet on Saturdays, and we had to video call in a class in Gadsden. So there's that kind of distance learning where you're like video calling another remote class. But I don't know if they mean distance learning here, or even just any sort of online class where you watch a video and then answer questions.
That's just with boys.
Well,
That's a very old meme, but
when you get your master's degree, they put classes on Saturdays.
Oh, ridiculous. What are your doctors?
Well, I'm sure it's even worse. I'm sure you don't ever sleep. Okay, so one, it says, show that this is a legitimate probability model. What can we do to prove that this model is legit?
Proof. Well, you have a X and a Y.
Okay, what are we supposed to do? What makes perfect
You
sense?
add the probabilities and add to 1.
And it should, because shouldn't percentages add to 100%?
Yes.
So if we add up 0.57 plus 0.17 plus 0.14 plus 0.12, if that adds up to 1, then we're good to go.
It
does.
Well, then we're good to go. That's how we showed it was a legitimate probability model, because it was supposed to add up to 1. It says, find the probability that a student selected at random is not in the traditional age group. So they're saying this is traditional. What's the probability of not the traditional?
1 minus 5.
43.
Yes, to both of you. I appreciate Sally for giving us the 1 minus that. If you remember what vocab term, yes, I need to get, yes, you can have a point. Get out your strip. And Hunter can have a point too. And then your group gets a point because he answered the question. Sorry, I don't know why I did that. I'm still trying to figure out what vocab term was that though, Sally?
Oh.
When you did 1 minus that.
Independent.
Who's lying?
Compliment rule?
Yes, yes, and you can have another point for that. We're doing the compliment.
2 points.
Okay, so, but if you didn't realize it was the compliment, how else could you have gotten to the number of 43?
You could have added the other ones together.
You could have added this 0.17, the 0.14, and the 0.12 together. Yes, perfect. Okay, so now last question. Find the probability that a student selected at random is 30 or older.
Well, yeah, the probabilities of the last two.
Yeah.
Okay,
That's it.
and that's going to be,
26%.
yeah, so we just add, and it's exactly what you thought it would be. Okay, why do we not have to, like, subtract and overlap here?
I mean, you could.
Because there is none.
Why is there no overlap?
Because the numbers don't connect. It's 30 to 39, and then 40 and up is its own block.
You can have a point. There is no overlap. So if there is no overlap, that means that they are vocab term that would, yes.
Are we doing vocab this section or no?
Ish is, so far, it's just independent,
That didn't really
compliments.
work out very well last time.
Co-determination.
I'm just saying, it
Yeah.
didn't work out well last time.
Oh, no, last chapter was like vocab chapter. No, this chapter is not a vocab chapter. But if you don't know like the 4 vocab terms, then how do you know the problems?
Okay, yeah.
No, you will very shortly. Like they keep repeating. Okay, I'm tired. You read.
Two-way tables and probability. We are trying to find probabilities involving 2 events. A two-way table can display the same space in a way that makes probability calculation easier. The best way to approach these types of problems is to ask yourself, what number should go in the numerator, and which number should go in the denominator? Your teacher will walk you through the next example.
Okay, you actually already saw a two-way table in your probability intro thing you did the other way. Okay, keep reading.
Students in a college statistics class wanted to find out how common it is for young adults to have their ears pierced. They recorded data on 2 variable genders and whether the student had a...
Wait, 2 variables, gender and whether.
Why is it
I don't know.
It's supposed to be like a hyphen, like not a hyphen, but like a
a dash?
It's a PDF. I can't fix it. Roll with it.
It's a dash, right?
variables and then gender and whether.
Yeah, gender and whether the student had a pierced ear for all 178 people in the class. The two-way shown on the next page displays the data.
Okay, well, it's right below. I don't know what it says next page. Okay, what should I do to figure out the totals?
Well,
Add.
yeah,
Add them.
Okay, if I add 19 plus 71, I get 90.
90.
That doesn't make sense.
Yes. It's
I don't
90.
like that.
And then if I add up 84 and 4, I get 88. So if I add them together, I get 178. Yay! Wasn't there 178 in the class?
This is true.
So we know we're right on that one. I put 75 here because 71 plus 4 is 75. And then 19 plus 84 is 103.
I know.
Plus, we could have just done 178 minus 75, and that should have worked out as well. Okay. The last two-way table we already had filled in. So this is the first one we've actually had to fill in. Sometimes they might put a blank. Well, not really. You had to do one with blanks on the columns, and you
Yeah.
figured it out with the Wolverines and different mascots. So never mind. You've already done harder ones. Okay, so answer the following questions. Suppose we choose a student from the class at random. Find the probability that the student has pierced ears.
That'd be 103 over 178, right?
Yeah, makes sense.
Yes, because there are 103 total with pierced ears. So 103 over 178, and when you type that in your calculator, you get
63%.
Or 0.6. Does it matter whether we put percentage or decimal?
It doesn't matter if you do 0.58
Dang it.
Oh, 58.
or if you say
Because
58%.
you led me astray.
I know, he was. I knew he was, but he said it so quickly. Yes, dear.
I like your Thanksgiving decoration.
Thank you.
Where-
Thank you.
What?
Discreet actually gets to work on that, not you. You don't have
Aw.
time for that. Okay, part B says,
Tom Turkey.
oh, and then I have not actually used proper notation in my answer. So we talked about maybe I should do probability of, and I'm going to put E for pierced ears, is 103 over 178, which was the 0.58.
Well, I was thinking you put the.
P for pierced ear? I don't know. It doesn't matter.
Okay.
You might want to explain.
And then N for not. Or you could do yes or no, so like Y or N.
PY or PN. Yeah, that would work.
6.
Okay, so number 2, it says, or number 2, part B says, is male and has pierced ears. So what is that?
So you add,
That's it, though.
but it's 19 over 170, right?
Okay, is she right or is she wrong?
I don't know.
Back in my younger days.
Well, you're right, yes, I'm assuming it's right.
Is she right or is she wrong?
Nobody says so.
I see that.
Is male.
We're out on Friday.
Is male and has pierced ears, that would be just 90 plus 84
What?
divided by 178.
What?
No,
Wait,
It's
no,
just-
I'm on the third question, don't disregard
It's
that.
19.
19.
It's just 19.
I'm on the third question, disregard
Yeah,
that.
19 over 90. I think it'd be 19 over 90 because it has to be male, right?
Why?
Because it was defined to be a male, and you're discussing whether or not he has pierced ears or not. So not to be 71.
Okay, that is a good question. That is a good question. And you're thinking about when it says given male, what is like it probability of he has pierced ears given male. If it has the word given, then that starts being conditional probability. We actually don't know for sure it is a male. They're asking what is the probability of being both male and pierced ears. So if male, we knew it was either 19 or 71. Pierced ears narrows it down to the 19. Okay, so 19 over 178, you get 0.106, so I'm going to say that's 11%. But I've not used the proper notation. So I'm going to do P of M for male, and then and, so what symbol am I supposed to use for and?
Upside down U.
And then I'm going to do E for pierced ears like I did before.
That's it just says you.
Yeah.
I did the or, I don't know why. The A was supposed to, the and looks like an A, like I told you.
Admitted.
It looks like an A. Goodness gracious.
8 points.
That was
I have a
terrible.
question.
I have an answer.
At what point do you like to start including the decimal when it comes to percentages,
Yes.
if at all?
I normally write down to 3, but when I round up to the nearest whole, because you don't normally hear like 11.5%. You normally hear 12%.
Yeah.
So I put the decimal version and then I round to the percentage. That way, if they were being picky, I have both.
Okay.
They can't get mad. Okay, is male or has pierced ears?
It's 155 over 178, I think.
It shouldn't be, it should be.
Because you have to subtract the 19, right? Because
No.
it's
I'm
overlap.
so lost right
If
now.
you just
guys.
do 90 plus
You haven't done the
84,
intro activity, that's why.
Wait, but you have to subtract the overlap, right?
not if you
So-
do 90 plus 84.
What?
I did 71 plus 84.
Well, you have to count them being male in the first place.
No, but that's you counting the 19.
There are 90 males total. I agree with that.
We go back
Plus
to
the
the,
84 females that have pierced ears, because
Okay,
it
well,
says
it's
4
talking
pierced
about
ears,
males.
period.
Oh, I see.
Or.
Yeah,
So
it's male
the
or
probability that we
has
pull
pierced
someone out and they're male or they have pierced ears. So it's still counting girls with
so you
pierced
add
ears.
71 and 84, right?
You would add 71 and 84, right? 71 of no.
No, you would add 90
84
and
of
84.
yes. Wouldn't you add 90 because there are a total of 90 men?
90 and 84.
And 84 because there are
I see.
84 with just the pierced that are females.
Holy God.
But if you wanted to do it with the formula, could you do the 90 plus the 88 and then subtract off the 4 that overlap? Yes. Okay, so, I'm sorry, I finally understand the question. So yes, 90 plus 84 would be easiest. And if you understand, I've already gotten the male, now I just need the female pierced ears to add those two together. That's great. But if you're like me and you're a creature of formula habit, you're like, well, I know I'm supposed to add the 90 for the males, and then I'm going to add maybe the total of the females, and then just subtract out the nose, or the
Why are you
overlap.
subtracting 4?
Yeah, I was gonna say, because it provides you with the 84.
So I'm just saying, if you didn't understand how you got that, you could have done 88 minus 4 to get the 84. Maybe you added up all the females and then just subtracted out the 4 who are no. Because someone had said something about the 88, so I was trying to incorporate it somehow in how I got the 174. But seriously, as you understand, the 90 and the 84 were the easiest, agreed.
Yeah.
Okay. Whew. Deep thoughts.
Then would you not subtract 19? Because that's the combination of both male and the piercers.
Wait, don't we have to divide by the total now?
There are so many words being said.
Don't you subtract 19 because you subtract the and of the two? No?
I thought you would have to.
If you added the total of yeses and the total of males, then we would have to subtract 19, because that's what it's saying.
If we had done the 90 plus the 103, then yes, we would have subtracted the 19.
That would have been the easiest way.
Yeah, that's what I was seeing.
Gotcha. You're already.
We're trying to make it too complicated.
But, I mean, yes, I knew he's like me and we're formula people and they're supposed to be and you subtract the overlap. But seriously, if they've already given you a two-way table and you know you've added up all the boys and now you're just needing girls with pierced ears, 90 plus 84 would be the easiest way to go.
Trying to do it that way just confused me, and then I ended up adding up numbers, so
Yes.
that makes more sense to me.
No, that I understand. Okay, you like to read. Read the paragraph.
Venn diagrams are another way to illustrate probability concepts. We generally draw a circle for each of
Two can have a point for listening to two. Listen to two as she goes again.
Venn diagrams are another way to illustrate probability concepts. We generally draw a circle for each event inside of a rectangle, the table space, and write in the raw number of individuals who are part of each event. Circles are usually exclusive. The circles should not overlap since they have outcomes in common. If the circles do overlap and they have outcomes in common, we would write in the raw numbers of individuals who are part of both events in the intersection of circles.
Okay, so like with our last example, there were some boys who did have their ears pierced, so there is some overlap. But, there is no overlap between boys and girls. That you're either a boy or you're a girl. Well, we're not going there, but theoretically, that's two separate circles. Okay, well, we had this whole discussion the other day about that. Okay, read the exercise, because I just can't.
Using the data from the previous two examples, make a diagram to illustrate the given information and answer the same questions as above. Let event A represent yes and event B represent no.
Okay, so they asked us to have two circles. One is going to be A, and one is going to be B. What am I supposed to put in the overlap?
Why do the diagrams have to be in a rectangle?
They always do that as a sample space. I don't know why. I'm curious.
You're going to have a dark.
Why? What number should I put in the overlap between A and B?
7.
What?
You're guessing things. You're not
I
actually
thought you
looking.
just said like any number.
No.
From the table.
Using the table. A is males, B is pierced ears.
0.
Oh, the
wait,
14, right?
The overlap.
There's no
19.
14.
The overlap of male and pierced ears is 19. My 19 is not really showing, but it's a 19. Okay, no, because that was silly. Okay, what other number should I put inside circle A?
Put down.
It's supposed to add up total to 90, yes.
71.
So I've got to put 71. Now, if I add the 71 and the 19 together, yes, total circle A is 90. Agreed. Okay, what number should I put inside circle B?
84.
4.
Is it 8? Circle B is supposed to be pierced ears.
Oh, it says 103. No, it's 84.
It's 84.
Okay.
And so we know the total of circle B, the total number of pierced ears is 103. 84 plus 19 is how we get that 103.
Yeah.
Okay, what number do I put on the outside? Because it's got nothing to do with male.
178.
178 is the total that all the numbers are supposed to add up to. What we're wanting to know is how many are really girls, or girls with no pierced ears, to be more specific.
4.
Okay, so if we're right, we know the 71 plus the 19 was 84.
Oh, that's why it's a rectangle.
The 71 plus the 19 was 90. Goodness gracious, I can do math today. We knew the 84 and then 4 more. So I'm just adding up 71, 19, 84, and 4. Does that actually add up to our 178? Yes, it does. So if you're having a moment when you add up all your numbers, did it add up to our original total? Yes, you've done it right. No, something went wrong.
Of course.
Okay, any questions about the Venn diagram? Okay, then let's flip. There's one more exercise and we'll call it a day. In an apartment complex, 40% of the residents read USA Today. Only 25% read the New York Times. 5% read both papers. Make a two-way table that displays the sample space, and then construct a Venn diagram to represent the outcomes. Okay, so the two-way table for the sample space. I probably should have done one more so I could have words.
Would you not have in the top thingy?
Not having the top thingy.
Would you not have it in the words and the
I don't know. I was having a moment. Have you never had a moment?
I'm always having a moment.
what?
I don't.
I had a moment
Just write
where
down the entire
great.
I've been having a moment for over 17 years. Just
Like,
it's all-
I thought I was right when I had 9,
I think
and then I was questioning my life.
Yeah.
Okay.
The word age.
So-
Between birth and death.
Yeah.
Okay, so I know one is New York Times. Are you going to put it across the top or down the side?
Across the top.
Okay, so I'm going to put the New York Times and then the USA Today.
And then both.
And then I'm going to put the word total.
That makes sense.
When you
So
get a
there's
chance,
only 4 numbers that are going to be in there?
I don't know. It doesn't look right, does it? Our other one had more than that. It had 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. I knew I was right to begin with. Darn you, Louise.
I don't understand.
Miss Conklin,
Absolute darn you. Yes, dear.
when you get a chance, I want to tell you something off topic.
Well, it's 2:58, so.
So, yeah, let's just call it. Let's get a new piece of paper. Louise, we got to leave room for the words. That's what I was trying to do over here when you started questioning my life.
The word off the top.
My ACT
You just have
test.
6 numbers.
So I was just going to do this. And then put the numbers down this way with total. And then this would be the total of the whole thing. Why?
I mean, yeah, but you still have 6 number spaces regardless, and it's fine, so you only have 6 numbers.
Can you believe him?
You only need 6 numbers, you have the 2 things for that, whether they read or not, whether or not, and they have the total side of one of them. You only need 6 numbers.
So my ACT prep class,
So when I'm about to eat, like,
And then you can always do, yeah, exactly.
and I'm not supposed to get free helpings.
so,
I'm gonna wait till I take that. I'll wait till gas station.
1.35.
Yeah, but it's over
I mean, I don't know why it is.
200% because 100% for each. I don't like it.
and all it took was to get pneumonia.
I don't like it.
Why it? For the percentages.
I have pneumonia, and so you like colorful.
And we should divide by 2, so it'd be back down to 100.
I love it.
I think you will multiply.
And then she still wanted to like go to swim practice. Like, what is
Why are you multiplying?
Yeah.
I don't.
I work
because
for
they're
the ship.
percentages, they're not like whole values.
Yeah, I know.
If they're whole
I have the
values,
whole
then
story.
you would add them.
I could have died.
You talk me into things all the time. You know this, right?
Right, like so you have. Okay, wait. Okay.
It's comfy tonight.
So you have
Yeah.
10 in the first
Yes.
column, and then 75% of 16 would be, what is that?
When I multiplied 0.40 times 0.25, I get 0.1. The other one's multiplied is 0.45. You add and you get 0.55. So that wasn't work. So
Favorite thing is
maybe it would be easier to do the Venn diagram first, then back up to the two-way. Why am I overthinking this?
I don't know. It doesn't make sense.
Because they did percentages, darn them. We've done all the others with totals. Why couldn't it just be with...
You make them 100 for each of them, and then give them the one.
You've just decided there are 100 residents, so therefore this is the answer.
Yeah.